Okay, for this screencast, we are going to do simple 1D interpolation. So I'm going to do myInterp1.m, and basically I'm just going to generate some, I'm going to do a clear, a CLC, a close all. So I'm going to just generate some data. I think we did an example problem in class that was 1, 2, 3, 4, and then y was 4, 4, 3, 1. And then I'm going to go ahead and plot that in with blue stars. I'm going to hit a figure. I guess I don't really need figure, but whatever. Anyway, so there we go. So there's my blue stars. 1, 4, 2, 4, 3, 3, and then 4, 1. Okay, so we could do least squares regression and all that, but for now I'm just going to do linear interpolation. So I'm going to go over here to Sakai. Here's my equation for linear interpolation. So basically the equation is, I change my notation every now and then. So y star is y0 plus, and I'm going to call this the slope here. So I'm going to call this m times, and then let's maximize it so we can see it, x star minus x0. X star minus x0. And then I'm going to say that m is y1 minus y0 divided by x1 minus x0. Okay, so then the question is we need to find x0, x1, y0, y1. So basically what these points are, it's you have x0 is less than x star is greater than x1 or equal to. And then the same thing for y0 and y1. So what we want to do is I'm just going to go ahead and use the find function. It's the easiest one. So I'm going to say find where x star is greater than x and find the first one. And so what's going to happen is it's going to say, okay, x star is undefined. So let's actually just make this a function. So function y star equals myInterp1 of x star. And so what I'll do is I'll just go in here and I'll say myInterp1 and I'll say 1.5. Okay, so what it'll do is it'll say the location is 1. So 1.5 is in between 1 and 2, right? So that means, and let's make sure this actually works because I might have gotten it wrong. I think, yeah, I did. So it's actually find where x star is less than x. So in this case, x star is 2.5. Is 2.5 less than 1? No. Is it less than 2? No. Is it less than 3? Yes, it is. So then if we run this, 2.5 is in between 2 and 3, so the location is 3. And then so what you can do is you can say x1 is x of location, x0 is x of location minus 1, and then y1 is just y at that location, and then y, and here, let me get rid of these semicolons. And then y0 is y at the location minus 1. And so if I run this, there's 2.5. See, x1 is 3, x0 is 2, and let's spit out what x star is just so we can see it. And I'm going to truncate location. So here we go. So if I do 2.5, my 2 points are 3 and 2. If I do, say, 1.9, my 2 points are now 1 and 2. And then notice that y star has been computed already. So I can go ahead and just plot x star comma y star, and I'm going to do a red star, and I'm going to make it a marker size of, say, 20. And so now, it doesn't like it. Oh, because x star is undefined, right? So here's 1.9. I forgot to hold on. Come back. Boom. So then there's my linear interpolation. So if I do it again for, say, 2.2, you notice that the red star is moved. If I say 2.8, right? And then what essentially is happening is I'm drawing a line between these 2 points and then finding where that point is. So if I do, say, 3.5, boom. Now notice this is interpolation. So if I do, say, 4.1, it's going to throw an error because 4.1 is extrapolating and you need to write a different code for that. But basically, if I do internal points, I can get my interpolation. All right? Good luck.